Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SHAHRIR bin ZULKARNAIN. I am from class DEM 2B S3 and my metric number is 14 DEM 20F1039.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Nama saya saiful SYAZANI AZINUDDIN bin RAHIM. Nombor metrik saya adalah 14DEM 20F1037. Saya dari kelas DEM 2B S3.
Hi, Assalamualaikum. We from group 8 want to make a presentation about title Volume of Revolution. In group 8 we have 3 students. First, me, Muhammad SHAHRIR bin ZULKARNAIN. My metric number is 14 DEM 20F1039. Second, saiful AZINUDDIN bin Muhammad RAHIM. Metric number is 14 DEM 20F1037. And the last one, Muhammad ABDULLAH AZZAM bin NORLIZAM. And the number is 14 DEM 20F1041. Alright, next. In this presentation, we have a few of slides. First slide about introduction. Second slide about the volume of a sphere. The third slide is about the volume of a cone. And the fourth slide is about another example. And the last one slide is about rotating a curve about the y-axis. First of all, I want to explain about introduction. Introduction first. Suppose we have a curve y equal to x. So this is the graph. You can see y equal to fx. We have x equal to a and x equal to b. We have a curve, and this is the explanation. Imagine that the part of the curve between the ordinate x equal to a and x equal to b is rotated about the axis of 360 degree. The curve will then map out the surface of a solid as it related. Such a solid are colored solids of revolution. If the curve was a circle, we will obtain the surface of a sphere. If the curve was straight line through the origin, we will obtain the surface of a cone. Now we already know what the formula for the volumes of a sphere and a cone are. But where did they come from? How can they calculate? If we could find a general method for calculating the volume of the solids of revolution, then we will be able to calculate, for example, the volume of sphere and the volume of a cone, as well as the volume of more complex solids.
Okay, we go through the introduction. To see how to carry out this calculation, we look first at curve. Together with the solid, it maps out when rotated through 360 degrees. Now, if we take a cross-section of the solid parallel to the y-axis, this cross-section will be a circle. But rather than take a cross-section, let us take a thin disc of thickness x, with the face of the disc nearest the y-axis at a distance x from the origin. The radius of the circle face will then be y. The radius of the other circle face will be y plus y, where y is the change in y caused by the small positive increase in x. The disc is not a cylinder, but it is very close to 1. It will become even closer to 1 as x, and hence y tends to 0. Thus, we approximate the disc wheel with a cylinder of thickness of height x and radius y. The volume V of the disc is given by the volume of the cylinder pi r square h, so that volume equal to pi y square x.
So the volume V of the solid of revolution is given by V equal to limit dx equal to 0, sum of series dV x equal to A to x equal to B, equal to limit dx to 0, limit sum of series pi y square dx x equal to A to x equal to B. This equal to integral BA x y square dx, where we have changed the limit of the sum into a definite integral using our definition of integration. This formula now gives us a way to calculate the volume of solid of revolution about the x-axis. Key point: if y is given a function of x, the volume of the solid obtained by rotating the portion of the curve between x equal to A and x equal to B about the x-axis is given by x equal to integrate BA pi y square dx.
The volume of a sphere. The equation x square plus y square equal to r square represents the equation of a circle centered on the origin and with radius r. So the graph of the function y equal to square root r square minus x square is a semicircle. So you can see on the graph there's negative r and curve, semicurve and r. This graph is y equal to square root r square minus x square. So next, we rotate the curve between x equal to negative r and x equal to r about the x-axis draw 316 to form a sphere. Now x square plus y square equal to r square, and so y square equal to r square minus x square. Therefore, V equal to integration BA by y square dx equal to integration r negative r by r square minus x square dx equal to pi r square x minus x cube per 3 equal to pi r cube minus r cube per 3 minus negative r cube plus r cube per 3 equal to, the last answer is 4 pi r cube per 3.
Okay, we go to the volume of a cone. Suppose we have a cone of base radius r and vertical height h. We can imagine the cone being formed by rotating a straight line through the origin by an angle of 360 degrees about the x-axis. Then the gradient of the straight line is tangent, and from the right angle triangle we see that tangent equal to r per h. Thus, the equation of the line is y equal to rx per h, and the limits of integration are from x equal to 0 to x equal to h. So, volume equal to integral BA pi y square dx equal to integral h0 pi in bracket rx per h square dx equal to integral h0 pi r square x square per h square dx equal to pi in bracket r square x cube per 3h square h0 equal to pi in bracket r square h cube per 3h square minus 0, and the final answer is pi r square h per 3.
Another example, the curve y equal to x square minus 1 is rotated about the x-axis through 360 degrees. Find the volume of the solid generated when the area contained between the curve and the x-axis is rotated about the x-axis by 360 degrees. From the wording of the question, a portion of the curve traps an area between itself and the x-axis. Hence, the curve must cross the x-axis. To find the point where this happens, we need to set y equal to 0. So we need to solve the equation x square minus 1 equal to 0. Factorizing x equal to 1, x plus 1 equal to 0, and therefore x equal to 0 or x equal to minus 1. Here is a sketch of the curve. We calculate the volume as follows. V equal to integrate VA pi y square dx equal to integrate 1 negative 1 pi x square minus 1 square dx equal to pi integrate 1 negative 1 x power of 4 minus 2x square plus 1 dx equal to pi x power of 5 divided by 5 minus 2x cubed divided by 3 plus x integrate 1 negative 1. Pi equal pi 1 divided by 5 minus 2 divided by 3 plus 1 minus negative 1 divided by 5 plus 2 divided by 3 minus 1 is all equal to 16 pi divided by 50.
Alright, for the last one, rotating a curve about the y-axis. Okay, we have looked at how to find the volume of a solid created by rotating an area about the x-axis, but we can also rotate an area about the y-axis. How can we find the volume in the case? So we look at the graph. You can see x equal to f, y equal to d, and y equal to c. We can see the curve. And for the explanation, to carry out such a calculation, we must interchange the rules of x and y. First, the equation of the curve must be given as x equal to fy rather than as y equal to fx. And secondly, the limits must be given in terms of y as y equal to c and y equal to d. Thus, the formula for the volume becomes v equal to v equal to integration dc pi x square dy. That's all from us, group 8, and I just want to say that I hope you enjoyed the presentation, and I want to apologize about the mistake that we make in this presentation, and that's all that I want to say, and goodbye and thank you.